Hi everyone, welcome to Pepcoding. So in the continuation chapter of emerging trends, now we've reached on to our last subtopic, that is blockchain technology. And let me tell you, this topic is also equally important as our previous topics. So do give equal importance and do have your ears properly on whatever I'm saying. Until the end of this video, stay tuned till the end of this video, and for sure you'll understand every point about blockchain technology. So let us see what is a blockchain technology. So basically, blockchain technology, it was firstly introduced in 2008. When we talk about blockchain, what do we understand? Basically, if we have one word, block, CHAIN, blockchain. Now, if we break this one word, this single word into two words, then what do we get? Block plus chain. That means chaining of blocks basically means blockchain. Now we have blocks like basically currently you can think any kind of block, and when we chain these blocks in any manner, this is actually referred to as chain of blocks, that is blockchain. Anyhow, they are connected and interconnected to each other, and that is the way they are termed to be as blockchain. So basically this is a naive thinking. Uh, so that is what we actually mean by blockchain, and it was introduced in 2008 firstly. So coming to the definition, what actually blockchain refers or means. So blockchain typically refers to the transparent, trustless, publicly accessible ledger that allows us to securely transfer the ownership of units of value using public key encryption. I'll tell you about this also, what public key encryption means, and proof of work methods. So basically, blockchain, what it means, I'll firstly correlate it with an example. What previously used to happen? Previously, we would have one big server, one server where all the data of our nodes, of our computers, would have been stored. We would have stored the data. Even currently, also this scenario is going on. But like, what would happen if we would have if this server would have like all the data, and in the worst case we can assume that if this server has been destroyed, if like something has happened to the server, or wherever our data has been stored, this big PC somewhere, it has been destroyed. So what happens, all the data of these PC, all the nodes, the data of these nodes are destroyed, and somehow the link is broken, and anyhow it misleads it, like the data is totally vanished, and it will give huge like destruction to the data, and everything is gone, everything is basically gone, because today everything is totally about data. Everything whatever we see in our day-to-day lives, it's about data. Your name is also a data, my like age is also a data. So each and everything, your bank account details is also in data. So if anything has vanished, means if anything has been broken, if the main server has been destroyed, so basically our data has been destroyed. But now what happens, now what actually after blockchain has come, what the scenario is, there is no particular ownership. As I told you that there was an owner, and it had nodes, computers or data, whatever the data of the computers used to be stored in that big PC. But now after blockchain has been introduced, what happens is there is no particular owner. Basically this was the upper case was a centralized case. It was a centralized case where this was the central element, and everyone was pointing this one only, the central node and central computer, and there only our data was being stored. But now blockchain, what it means, the main definition out here comes that blockchain is particularly decentralized. So first point you should remember, that blockchain is decentralized. Yeah. So blockchain is decentralized means it doesn't have any of like big node or anything which is connected to everyone. But what out here happens is it is interconnected to each other via hash codes. So basically via hash code means, I'll tell you about hash code. Basically you currently need to understand that there is no any big server or anyone who is holding this every data out here in blockchain, but everyone has their own data and everyone is pointing to some other data out here. So what actually happens, I'll tell you in a board. Just a second. So what happens is, I gave you two cases out here. I gave you two cases where one case was the normal case previously. In normal case, what would happen was normal case, and after blockchain introduced. Blockchain. Blockchain. So in normal case, what we saw was, we had seen that we had a big server and the nodes were connected to them, and if one single node has been destroyed means nothing has happened, but if this node has been destroyed means everyone has been destroyed. But so this was basically what it was it was centralized. It was centralized. So it was following the rule, like it was following centralized rule. But now in blockchain, what we saw, that we have group of block. So basically block means transactions or records, anything, or data. We can say block means a node which consists, which like contains data in itself, full of data, and this data, like these are nodes, and or we can say blocks. Now when these blocks are chained with each other, then it is termed as blockchain. Anyhow, somehow or the other they are chained to each other. So now when this chaining happens, so this is termed where blockchain comes in. So the data is there is no centralized data out here. Like there is basically, this is the point where we talk about decentralized. Sorry for the poor handwriting, but this is where we talk about decentralized way of storing data. So out here there is no owner. Like we talk about we'll talk how we'll understand is basically we have an owner, and this owner is basically having so many like slaves, and this owner is paying to the slaves are doing their work and storing, giving their work to the owner. So when a slave has like left the company means nothing, no like destructions are happened to other slaves or other people. But if the owner has only like closed his company, then every person or every working person out here, they'll be destroyed, because their income or their data was actually stored with this owner only. So if owner has gone, that means everything is gone. So centralized basically is a bad way of connecting networks. But decentralized, you have a friend, and you are giving something to your friend, and like your friend has also stored that thing to another friend. And if one friend has gone, no worries, I'll talk to another friend, I have that data in another friend too. So out here there is no particular as such that someone is owning or someone is handling that stuff. But in centralized, there was the poor case that every thing was stored in one particular place only, and if that place is destroyed, that means everything is destroyed. But in decentralized, what we saw was everything was particularly stored in blocks, and blocks were chained. Blocks were chained only in one condition, that blocks are filled with data properly, it is validated. So after validation, basically what validated means it has correct data in it, and after that data has been stored particularly in that block, and after that block has stored the data, it is chained, and furtherly the chaining of the blocks basically makes a blockchain technology. And this is blockchain basically follows decentralized way of storing or connecting networks or connecting the nodes. So basically if one has been destroyed, that means no worries, if this has been destroyed, so also have the connection to another node of going, if I want to reach out here, and I had one way of storing, I had one way of going from this way and then coming out here. But if this has been destroyed, if this path has been destroyed, then no worries, I have this path also, I have this path also, I have like plenty number of paths. So basically blockchain, this is just a small representation, but in a blockchain we have a huge number of ways to store the data. and they are basically decentralized, one place to another. It's a very giant network. Where basically we, yeah, if a particular term is given to it, so we say peer to peer node. If we say peer to peer node, this is how blockchain is referred. That peer to peer, basically it works in peer to peer way of transactions, one friend to another. So if I want to reach to this node, I can even go from I can even walk from this path. Just a second. Yeah, I can even walk from this path. I can come out here, or if this path has been destroyed, I can even come walk from this path and reach out here. If this path has also been destroyed, I can go from here, then again I can travel and come out here. I have this path also. I have plenty number of paths. This is just a simple or very tiny representation which I'm showing out here, but I have plenty number of paths. That is the main feature of blockchain, that it is decentralized. Your data is not being shown to another people, but you are anyhow interrelated to those. If something has happened to you, then no worries, your data won't be lost, because no one can even destroy your data, because that data has also been saved to another node, and it has been saved to all the nodes that are interrelated or interconnected to each other. And if one has made a wrong data in their node, so no worries, other nodes are basically storing the correct data, and other nodes will point it out that this node has basically the wrong data. So in decentralized, we saw how it is beneficial. This is the total representation how a decentralized is beneficial. So coming down, we have one main topic, uh, how this part was actually called as client server. I also had to mention, this was called as client server representation, client, client server representation or model, we can say client server model. And this was peer to peer peer to peer model, correct? So this was a peer to peer model, peer to peer model. So you may also be thinking, how does this blockchain actually work, like how one node is storing, like how it is connected to other nodes. So yes, we have a very good answer to that. So basically you might have heard about hash or hashing, so no worries if you've not even heard. So hash, so what this means is, if I am storing, basically if you have studied about linked list, though it has no representation with linked list, but still if you have studied about linked list, so what we used to do in linked list, that we had one data and we had address out here. This address was the address of the next data, and again here we had data, this was, here we had address of the next data. If the address out here is 2, so basically here it was stored 2. If the address out here is 3, so basically it was stored out here 3. Basically it will point to 3, it will point to 2. If anyone is lost, then these 2 would know that yes, 3 is lost, because after me only 2 was I was pointing to 2, so where is the 2? I need the 2 back. So likewise, in linked list we used to iterate. So linked list is basically a data structure topic. You don't need to even think about it if someone knows. So I'm just giving more familiar example so that you can correlate with linked list. So now if you even don't know, then no worries, I'll tell you about what actually a hash is from very basic. So in a hash, what actually happens, I'll make this image a little bigger, so that you can correlate with whatever I'm trying to say. So just, so now what I meant by hash is, yes, so hash basically means you are having, or you are storing basically the address of the previous node in it. Every node is storing the address of their previous node. Or in a hash, what happens is, if you are having an address out here, address out here, address out here, address out here, address out here. So this is the address of the previous node. So if this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So basically out here what will happen, this will store the data of 1, this will store the data of 3. Before it also some block would happen like 0, so this will store the data of 0, this will store the data of this is 5, so this was 3. This will store the data of 5, this will store the data of 6, this will store the data of their previous node. Likewise 0, 1, 2, 1, 2, 2, this will be this 4, 4, 5. So likewise what happens is hash is the main key role, like main point which plays the main role out here in blockchain. How? Because hash only stores the address of the previous node. So in this what actually happens is if one block is lost, so we'll come to know because this block has the address of this block. So if this block is lost, this block will totally identify that yes, I was having this block as my address, but I'm not getting that block anywhere. So it will give the like information or the data that I'm missing, my address is missing. So likewise it is totally secure that if one block has been lost or one block has been destroyed, so that data is with us, that which actual block has been destroyed, or how can I relink it with that block again, how can I bring that block again. So if in a centralized which would have been lost, we would have seen that we don't know which actually lost, but it lost, it has somehow gone, it has no relation. But out here everything has a relation because a hash basically stores the address of the previous node. So stores the address of previous node, address of previous node, okay. So basically you may have understood that how decentralized network works, because they work as they store the data of the previous node, because the previous node will particularly let us know that what actually our node was storing previously. Now coming to encryption, I also told you that I'll be telling about encryption. So blockchain basically how it works as like it provides you public key encryption and public key encryption, and also it gives you private key encryption, right? So what actually this public key encryption means is, public key encryption means symmetric key, basically symmetric key, METRIC, and private encryption means asymmetric. So symmetric and asymmetric, basically what it means is, what it actually means is that symmetric key means one node is out here and one node is out here. Basically this is the way how I'm talking about the point how blockchain is secure. So when in terms of security we have two keys, that is public key and private key. So what actually public key means, it is symmetric key, and what actually private key means, it is asymmetric key. Now what does this symmetric key means? Symmetric key basically means that while we are transferring a data, in between we have lots of users or lots of people, lots of hackers who can hack our data. So that is why we use this key for encryption. Encryption means like protecting our, or basically changing our data into some form, or basically cryptography, changing our data into some form where the our data is particularly not available as whatever we had seen. The plain text is not the same, the text is not the same, but it is it has been converted to ciphertext. So ciphertext is a code. We don't need to go deep inside this because it is not in your syllabus, but ciphertext is a basically a code which is not understandable to normal, like understandable to people, but it is understandable to the machines unless and until we decode it again. We decode it and only authorized persons can decode it. So basically symmetry key, what it does is whatever data we are sending Hackers may hack in between, hackers may change the transaction. Just assume that we have bought 10 bitcoins out here, and hacker may in between do, like we have sent the money of 10 bitcoins, and like the transaction is being in process, and only the money, like the hacker has taken the money of 9 bitcoins and it has again sent 1 bitcoin's money, and only 1 bitcoin has been assigned to this person, while this person had sent the money of 10 bitcoins. So he's 9, the money of 9 bitcoins, that is huge amount of money, has been stolen by the hacker. So how we like secure this by blockchain is that we provide public key encryption. That is basically we provide a key, or basically what happens is, in between there we there is a key, whatever we basically whatever the data we are like sending, this will be changed to a code, right? And this code, the key of this code will be only with the person that is sending, and the same key will be with the person who is receiving, so that like the sender will have the key because he needs to encode it. He needs to like encode it, means it will protect it, it will encrypt the data, and after that the receiver will also have the same key, because it has to again decode it has to again decode the same text. Suppose I'm texting hi, so this hi has been gone and it has been changed to something, any symbol has 247, and in between something as like this is the encryption out here in between way, and to receive the same hi the person needs to have the same key. If he applies the same key, so he'll get back the hi out here. So hi was in the starting, in between it was encrypted with any code, and after that again applying the same key will give him back the hi. But in asymmetric key, basically in symmetric key, what we saw, both the sender and the receiver will have the same key, right? But in asymmetric key, we don't have the same key, we have different key. It is also the same case in asymmetric key. What happens is, we have two cases that it will encrypt our data in between, right? But the sender will have this like different key, he will like encrypt it with different key, but the receiver will like encode it with different key. This is actually available for private transaction, where we only want our data to be taken by only one person, so we give one key to that person, this is your key. In public key, what happens, we give the same key, this was my key also, so this is your key also. So in private key, I don't want the receiver to know my key, so I'll give him one particular key, that is your private key. In asymmetric, basically means that you have a different key to encrypt my or encode my, basically decrypt my data. So it was encrypted out here, and while receiving he'll decrypt it with this. So this is how blockchain was secure, because what it used to do was, it used to basically in between the transaction, it used to not let anyone see what actually the transaction was. It used to convert the basically sentence or plain text into some machine code which no one could ever understand unless and until they decrypt it. And for decrypting, they required the special key which is only present to the sender and the receiver. The sender and the receiver, if they are having the same key, then it is called as public key, public, public key. And if the sender and the receiver are having different key, so it is said to be as private. So this is what all blockchain technology was. Also, like uh, do refer to the notes which I'll be providing, and also read the definitions of whatever I've mentioned in the PPT out here. Because this is what actually I've explained in my board also right now. However, like blockchain is like growing day by day. I hope you may have got lots of insights about what actually blockchain is, how it actually works, basically what actually the role of blockchain is, what actually it is doing. I'll also explain you this figure, just a second. So this figure, it actually demonstrates means, it lets you know about what our, okay, just a second. Yeah, so from this figure, what we understand is, let me clean the board. So whatever I've told you, that actually has been demonstrated in this image. So firstly, a transaction is requested, and after that request transaction has been checked, like basically peer-to-peer node. Like it, I told you that everything is a peer in blockchain. After that, nodes are validated. I even told you about validation, that it will check that whether the same data has come or not, whether the data is correct or not, whether the transaction is correct or not. So it will be verified transactions will be out here about the cryptocurrency or whatever data it is. The transaction will be combined with each other, building a block. So after that, once the like basically data has been or the data has been verified, yes, you are correct, so this will create a new block, and this new block will be particularly and permanently added to the blockchain. So blockchain, it will be added, and lastly, after it is chained, so this blockchain will complete its transaction. This is how actually blockchain processes, and it is very secure, and it is like totally, it is demanding also, because it is increasing day by day, right? It is increasing day by day, and this is the definition which I've totally explained in the same thing. Hope you understand what blockchain is. Stay tuned. You'll learn about further like chapters of Python in the next video. Stay tuned, and thank you for listening to me.